Math 2. This is our lesson 5, which begins on page 39 of our workbooks, squares and circles. So we're going to review some algebra concepts from last year. So let's take a moment, and I would like you to pause this video and see if you can remember how to do these problems, this multiplication from last year. Welcome back. I hope that it went well for you. Let's take a look at the first one and the third one. And so if you had some trouble doing them on your own, maybe after we do those two, you can go back and look at the second and fourth. The first one is an example of the distribution property. I have a 5 outside my parentheses. This is equal to 5x plus 5 times 3, or 15. 5 times this binomial is 5 times each term. So now we're looking at 3. I'm not sure how you learned how to do this in your algebra class. A lot of students like something called the box method to multiply binomials. So this is a binomial, 2 terms, x plus 4 times x plus 2. And so students would draw a box that is 2 by 2, and they'd write the x plus 4 on one. The plus really goes with the 4, it makes it positive. And the x plus 2 on the other side. It doesn't matter which side they go on. And then you multiply the x times x to get x squared. You multiply 4 times x to get 4x. It's a lot like an Excel spreadsheet right now. We're multiplying the column and the row. X times 2 would be 2x, and 4 times 2 would be 8. A lot of times when you do this, you'll notice on the diagonal you'll have like terms. You can add like terms. So this would give me x squared, 4x plus 2x is 6x, plus 8 as my answer. So this would be equal to x squared plus 6x plus 8. So pause the video if you hadn't done any of those yet. Pause the video and try the other two, and then come back. Welcome back. So on the second one, I'm hoping that you multiplied x times x and realize that when you have x times x, you have x squared, not 2x. That's x plus x. And then x times negative 3 would give me minus 3x. And then when I do this problem, I much prefer the box method for students if you don't have a preference, but some students also learn a method called FOIL. This is really distribution. In the sense, I'm going to take the x times both of these terms, and then I'm going to take this 5. I'm going to use a negative 5 since there's a minus sign in front of it, times both of these two terms. We call it FOIL because we use these letters to do our first terms, x and x, our outer terms, x and negative 5, our inner terms, negative 5 and x, and finally we're going to multiply our last terms, negative 5 and negative 5. So you might have learned it this way. So if I was going to do this one with FOIL, my first term, x times x, is x squared. My outer terms would be x times negative 5, or negative 5 times x. My inner terms would be a negative 5 times x, or negative 5x. And finally, my last terms is a negative 5 times a negative 5, which is a positive 25. Just like when you do the box method, when you do the FOIL method, a lot of times you'll have two like terms. I need to add my two like terms, and I get x squared minus 10x plus 25. Okay. So ladies and gentlemen, let's take a look at 5.2 perfectly square. So on this one, they'd like us to multiply these out. So now that we did several problems together, I'd like you to try this. I want to remind you guys of a popular error that happens when you have a binomial squared. So let's change this. Let's write x plus 3 squared up here. A popular mistake, and we'll talk about this in our Zoom office hours, students will just square the two terms that they see. So they'll write x squared plus 9, and they think that they got the right answer. That feels good to them. But actually, those two are not equal to each other. That is a diagonal line through my equal sign. Those are not equal. This is not correct. So an easy way to make sure that you don't make that mistake is anytime you see a binomial squared, I recommend to my students to write it twice. Usually when students see it written twice, so write it twice. In this case, Now students will remember, oh yeah, I have to either use box method or FOIL method. So pause the video and do these 4 problems and come back to check your answers. Welcome back, ladies and gentlemen. On our first one, hopefully you got dun, 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 x squared minus 14x plus 49. On the second one, x squared plus 8x plus 16. On the third one, x squared minus 20x plus 100. And on the fourth one, x squared plus 2x plus 1. If you're having a lot of trouble with these, please come to office hours and ask me questions about using the box method or FOIL. Whatever is your preference, you and I can do a few problems and see if we can figure out the issue you might be having. But each of these 4 are what we call a perfect square trinomial. Remember, a trinomial, tri means 3, is 3 terms. In this case, this has 1, 2, 3 terms. 1, 2, 3 terms. 1, 2, 3 terms. So for example, we would call this x squared plus 8x plus 16 in B a perfect square trinomial. This has 3 terms. That's why it's a trinomial. We call it a perfect square trinomial because when I factor it, it factors into x plus 4 perfectly squared. So that's why this guy is called a perfect square trinomial. Same thing here. This would perfectly factor into x minus 10 squared, and this perfectly factors into x plus 1 squared. So a perfect square trinomial is anything in the form of a squared plus 2ab plus b squared. A plus b squared. So taking a look at number 3, it asks which of these expressions are perfect square trinomials. So let's look at these. First of all, there's one that sticks out to me that would not be a perfect square trinomial. I'm looking at the 9, the 20, the 81, the 1, the 16. So there's one that sticks out to me that it would not be. The others all look pretty good, so I guess I would have to start looking at these middle terms to see if they fit my pattern. In my pattern here, if you notice, if this was 16, then I would have my 4 squared gets me 16, and 4 plus 4 gets me my 8. Up here, if you notice, my 10, negative 10 squared gets me my 100. Negative 10 plus negative 10 was my negative 20. So pause for a minute and look at these patterns and see if you can pick out your perfect square trinomials. Welcome back. So I'm hoping you picked out A, C, and D. Let's talk about why B and E are not perfect square trinomials. To begin with, 20 is not a perfect square. So all of my problems, 49, 16, 100, 1, 9, 81, and 1, my C term has to be a perfect square. So B is not. Now you might say, well, that has a 16. That looks pretty good. It does. But remember what my pattern is. Whatever this is squared and whatever this is squared, this has to be equal to twice that. So if I think about the square root of 16, it's 4. If I think about the square root of x squared, it's x. And this term in the middle is not 2 times 4 times that x. This is not 8x. So this is not a perfect square trinomial. For the purpose of our work in this lesson and in lesson 6, I'm going to be giving you perfect square trinomials. So looking at a perfect square trinomial, how do I factor it into its perfect square? I have a shortcut for you. The shortcut, you look at the first term and the last term and you think of their square roots. So the square root of 9 is 3, because 3 times 3 is 9, or you could do it on your calculator. And the square root of x squared, the square root and the square cancel to just x. So this factors into the binomial x and the 3, and where you get your sign is the sign of the middle term, my b term. In this case, it's negative. So that's a neat little trick we can use until we learn how to find our c term and write it as a perfect square in problems in lesson 6. So let's take a look at C, for instance. When I take the square root of 81, I get 9. That's what I'm thinking in my head. And when I take the square root of x squared, I get x. That's what I'm thinking in my head. So I know this factors into x and 9. And the sign that I want is the sign of my middle term. Now, if at any point you're not sure about this, think about how you could easily double check your answer. Write this twice, multiply it out, you're going to get this answer. You can be able to go back and forth that way. And finally, the last one then is the same idea up above in D right here. I would have my x minus 1 squared for that problem. The square root of 1 is 1. The square root of x squared is x, and there's a minus in the middle. And if you're not sure about that answer, again, box it out, multiply it out, FOIL it out, and you'll get this. So we just did number 4 up above. Okay. So let's take a look at 5.3. What does this have to do with a circle? Well, you might remember that our equation for a circle was x minus h squared plus y minus k squared equals r squared, where hk was my center and r was my radius. So this then brings me to this problem where it asks for my center and my radius. So when I'm looking at this equation, a mistake some students would say is they'd say the center was negative 2, 7. It's not. Remember, because the minus sign is in my equation, I need to think the opposite. So my actual h is really a 2, because when I insert a positive 2, it looks like x minus 2. When I insert a negative 7, it becomes a negative 7, and it looks like a positive 7. So this is where I have to remember to think the opposite in order to get my center. So my center for this problem would be positive 2, negative 7, and the radius of my circle is 10. This is 100. My radius squared, 10 squared, that's the number there, but what I want is my radius. So the radius would be 10. The square root of 10 squared is 10. So this is a circle, over 2, down negative 7, and then I would count up 10, left 10, right 10, down 10, and I could pencil in this circle that would look something like that on my graph. Better than my rough sketch. So let's look at B. It says apply the distributive property to the squared binomials and rearrange the equation so that one side is 0. This is the form in which many circle equations are written. So let's rewrite the equation from number 1. X minus 2 squared plus y plus 7 squared equals 10 squared. What they're really asking us to do is to multiply this guy out. So, for example, if you're a box method person, this is x minus 2 times x minus 2. So I would have x minus 2 times x minus 2. I would get x squared. Negative 2 times x is negative 2x. And negative 2 times x is another negative 2x. And negative 2 times negative 2 is 4. And I have my like term on my diagonal. So when I multiply this one out, I get x squared minus 4x, because they're like terms. I'm going to combine them. Negative 2x and negative 2x is a negative 4x plus 4. I'm going to do that all over again for my y term. So I have my y plus 7 times another y plus 7. Remember, you have to write it twice. And so I have y squared and 7y and another 7y, and 7 times 7 is 49. So again, I have my like term on the diagonal, and I get y squared plus 14y plus 49 equals 10 squared, which is 100. So now it had told me to solve it so that I have one side equal to 0. So I'm going to need to subtract the 100 over. So first of all, over here, I notice I have two like terms. So let's put them together. So there's no other x squareds, there's no other x term, there's no other y squared term, there's no other y term. Those guys I'm leaving alone. I do have, though, a 4, positive 4, and a positive 49, and that's equal to 53, and then equals 100. So I'm going to subtract 100 from both sides. line it up with the other like term, so they cancel. And I'll have x squared minus 4x plus y squared plus 14y. And be careful if you're going to do this in your head, when you're subtracting, even though the hundred's negative and but it's larger, you need to think about the subtraction problem in your head this way. And you know your answer's negative because the 100 was bigger and it's negative. Or you could bring out your calculator and do 53 minus 100. But just be careful you don't make a mistake trying to do that mentally in your head. And then this is the answer they want. This is often the way we see a circle equation. This equation is not that useful though, because I can't figure out my center or my radius. In your locker, if you've printed out our formula sheet for Unit 6, this is the Unit 6 formula sheet. This would be handy to have. This is that form. It's an x squared term, a y squared term, an x term, a y term, and a constant term, all equal to 0. So sometimes we use that form, and it looks like this. So generally, when we have this form, what I'm going to have to do is use algebra to rewrite it in this form. That's the next skill we're going to be learning. We're going to learn that in lesson 5, and then we're going to use it in lesson 6. So let's take a look at the problem in 2. This is the equation. I'd like you to underline the x squared, the 6x, and the 9. And I'd like you to underline the y squared minus 10y and the 25. And then separately, you can underline the 64 if you want. It says, how can you rewrite this equation to find the center and radius? So I want to rewrite this equation so that it is in this form. Something squared plus something squared equals my radius squared. So conveniently, on the previous page, you and I were taking trinomials, such as x squared minus 6x plus 9, and writing it as a binomial squared. That's what we'd like to do here. So again, I'm going to show you that trick again. In this problem, if I'd like to write this trinomial, this perfect square trinomial, as a binomial squared, I take the square root of the first term, square root of x squared is x. I take the square root of the third term, the square root of 9 is 3. And I get my sign from my middle term. So I know that this factors into x plus 3 squared. If you're not sure you did it right, if you're concerned, then just like we did up here, box it out and see if you get that trinomial back. All we did is we went from here back to this. We did it in reverse from number 1. So you can always double check by doing the box method or FOIL. So try the y term on your own, pause it, and see if you can rewrite this one as a binomial squared, and then come back. Hi, ladies and gentlemen, welcome back. I hope that you wrote y minus 5 squared. The square root of 25 is 5. The square root of y squared is y, not x. And my middle term is negative. And then 64, the square root of 64 is 8. This is 8 squared. So I can see that my center is, careful, it's not 3, negative 5. It's negative 3, positive 5. You have to think the opposite. And my radius of my circle is 8. Let's try doing a sketch, just a little sketch of it. So over negative 3 and up 5, 1, 2, 3, 4, and 5. This would be where my center would be, negative 3, 5. And then I would go up 8, right 8, left 8, and down 8. And I would pencil in my circle. And if I was doing it on graph paper, it would look a lot nicer. But I wanted to think about what that would visually look like. Okay, ladies and gentlemen, the next thing I'd like to draw your attention to is a summary. In this summary, it lists some perfect square trinomials and as a binomial squared. Why don't you cover up one side and do your box or FOIL method and see if you can come up with the trinomial, and then use our shortcut, taking the square root of the first and last term, and see if you can write it as a binomial since that's already done for you. And then there's another problem you can practice here. You can underline the x squared minus 22x and the plus 121. You can underline the y squared, the 2y, and the 1. And then this would be my r squared. And you could practice writing this into this form. You see the answer there. Just cover it up and see if you can rewrite this as a binomial squared, a binomial squared. This is your radius squared. See if you can find your center and radius like we just did in 5.3 number 2. Thank you.